Welcome to this video lecture on the subject basic electrical and electronic circuits. So in this lecture we are going to discuss about circuit elements. So let's see the need for circuit elements. So basic electronic components are the building blocks of functional electronic systems. So these components are required for every electronic circuit we used for everyday use. So the classification of circuit elements are active and passive elements, unilateral and bilateral elements, linear and non-linear elements, lumped and distributed elements. So we are going to discuss every classification one by one. So let's discuss the active elements. So what is the use of active element? So these elements supply energy or power in the form of voltage or current to the circuit or network we are using. So for example, voltage source, current source, batteries, generators. So these are the active components which supply energy to the circuit. Also transistors, operational amplifiers, these are also active components which used to amplify the voltage, and also it is used in very common electronic circuits. So these are the examples for active elements. And what are passive elements? So these components cannot generate the energy. They absorb or store the energy in the form of electrical field or magnetic field. So for example, resistor, it is used to control the flow of current in the circuit. So it does not provide any power gain. So and also capacitors and inductors, they are used to store the energy in the form of electrical energy or magnetic energy. So these are the elements used in electronic circuits as passive components. And unilateral elements. So what is mean by unilateral? So it depends on the direction of current or voltage. For example, it consists of a diode. So diode is a unidirectional device. So this characteristics change with the polarity of the applied voltage. So for the forward bias, diode conducts, and for reverse bias it does not conduct. So these are the examples for unilateral elements, diode, transistors. So their behavior depends on the direction of current or voltage. So these are the unilateral element. So for an example, diode used in a bridge rectifier circuit. So what is bilateral element? So in this bilateral element, the behavior is same for the both directions of current flow. So VI characteristics does not change with the biasing. For example, resistor, inductor, capacitor. So we apply voltage to the resistor, so characteristics remain the same. So these are the examples for bilateral elements. And what is linear element? So consider the circuit where resistor and inductor is connected in series with a voltage source. So these components obey the superposition and homogeneity principles, where the characteristics of voltage and current VI relationship is linear. So in this diagram, a graph is shown with respect to voltage and current. So the graph is straight line is obtained. So this is the linear relationship. So ideal resistor, ideal inductor and ideal capacitor are the examples of linear circuit elements. And non-linear circuit elements, here we consider a voltage source and it is connected to a diode and load. So this is the non-linear circuit. So diode conducts in the forward biasing direction. The characteristics curve VI is shown. Here the voltage is applied in the forward bias direction and the current is drawn in this VI characteristics curve. So we can see that here the relationship is non-linear. When voltage is increasing, current is increasing very slowly, and after a knee point voltage 0.7 it is increasing rapidly. So this is the non-linear characteristic. So examples are diode, transistor, SCRs. So next we are going to see the lumped element. So what is mean by lumped element? Here the components are individual. It can be separable. So the electrical parameters concentrated at a point in the circuit. So here the circuit dimensions are very small compared to the wavelength of the signal. For example, consider low frequency circuits. Here resistor, capacitor, inductors used in these circuits are lumped elements. So these components are very much smaller compared to the signal wavelength. So these are used in low frequency circuit. So these elements can be separated individually. And distributed element. So here the parameters or the components are spread along the length of the circuit. It means the resistor capacitors are distributed along the length of the transmission line. For example, we use coaxial cable, transmission lines, waveguides, etc. These are used in high frequency application. Radio frequency and microwave application, we use these distributed elements. So in transmission line, at every point we can have the resistor, capacitor and inductor, but it is not physically separable. So it cannot be separable physically. So these are the distributed elements used in high frequency circuits. So let's take the assessment. Which of the following is an example of a passive element? So options: battery, generator, resistor, operational amplifier. So as we have discussed in this presentation, the answer is resistor. It is a passive element. Remaining options are the active elements. So answer is option C. If the voltage current characteristic is a straight line through a origin, the element is said to be options: linear element, non-linear element, unilateral and bilateral element. So the VA characteristic is straight line in linear element. So the answer is A. Thank you for listening this lecture.